Hi everyone, in Algebra 3, this is going to be your new material in lesson 66, which is on formulas for system of equations and then phase shifts and period changes. So for our formulas for systems of equations, it's going to look something similar to what we have dealt with in the past. So you're going to have an equation that looks something like this, and they're going to ask you to solve for the variable x. Now using that, you're going to then be able to plug in numbers that will all be represented by each of those letters. So what I want you to do is we're going to look at number 17 and number 18 from this lesson. So for number 17, they asked us to solve this equation for x. And what you're going to do is after you do that is for number 18 is to use the results from 17 to solve for x. So if you can look at these two equations, once I solve for x, you can notice that the a is in place of where the 3 is, the b is in place of 2, c is 6, then the coefficient for x is d and 2, f, and then -4, and then g is 12. So you're basically doing what you were doing before, but then after that, you're going to use that information to then solve for the next problem. So we're going to start with doing number 17. So number 17, I'm going to solve my equation for x, which means that I'm going to multiply the top equation by, if I'm solving for x, I want to eliminate y. So I'm going to multiply the top equation by negative f and the bottom equation by b. So when I multiply the top equation by negative f, I get negative f a x minus f b y equals negative f c. Multiplying the bottom equation by just b, which would be b dx plus b f y equals b g. So now I know that my y's are going to cancel, and then I'm left with b dx minus f a x equals b g minus f c. Now I'm going to factor out the x, which would leave me with b d minus f a. Right side stays the same. And then when you solve for x, you're going to divide both sides by what's in parentheses. So x will be equal to bg minus fc over bd minus fa. So that would solve my equation for what x is equal to. And then for number 18, it says use the result of 17. So again, my a is where 3 is, b is 2, and then c is 6. For the second equation, d is 2, f is -4, and then g is 12. So for number 18, all I need to do is plug these numbers into this equation. So x will be equal to b, which is 2, times g, which is 12, minus f, which is -4, times c, which is 6, over b, which is 2, times d, which is 2, minus f, which is -4, times a, which is 3. Now all I need to do is simplify that. So I have 2 times 12, which is 24, and then 4 times 6, which is also 24, but it would turn into plus because of the two negatives. And then in the bottom, I have 2 times 2, which is 4, and then 4 times 3 is 12. So that would give me 48 divided by 16, and that means that x is equal to 3. And then obviously for this problem, you would want to make sure that you're following it exactly as it's given to you. So you want to make sure you are using your result from 17 to solve for 18. So if you're not doing that, then obviously on a test, you would not get credit for that. Okay, now we're going to do just some of the problems that relate to some of the recent lessons. So for number 10, the first thing that you want to do is you want to isolate your radical. So I would move the square root to the other side. So I get tangent x equals the square root 1 minus 2 tangent squared x. To get rid of the square root, I'm going to square both sides. That would give me tangent squared x equals 1 minus 2 tangent squared x. If I move the 2 tangent squared x to the other side, I would add it. And then 1 plus 2 would be 3. Tangent squared x is equal to 1. Divide by 3. And then because your tangent is squared, you don't want it to be squared, you're going to square root both sides. And remember that when you take the square root of both sides, you're going to split this into two separate equations. It will be tangent x is equal to positive 1 over root 3. And then tangent x is equal to negative 1 over root 3. So we have two equations. Now for the first one, I want to find out where tangent is positive. Now using my chart, all students take calculus. Well, I know that everything is positive in quadrant 1 and tangent is positive in quadrant 3. This is opposite over adjacent, so opposite is 1, adjacent is root 3. Opposite, adjacent. Now I know that that's a 30, 60, 90 triangle, but the adjacent angle is 30 degrees. So knowing that my adjacent angle is 30 degrees on this problem, I would say that my first one is going to be 30 degrees. My second answer is in quadrant 3, so I'd have to add that 30 degrees to 180, and that would give me 210 degrees. Now for the second one, I need to find out where tangent is negative. Now if it was positive in 1 and 3, that means it's going to be negative in the opposite quadrant, so 2 and 4. Now I label my sides as opposite 1 and adjacent as root 3. Again, you'll see that it's a 30-degree angle. And that 30-degree angle in quadrant 2, I would subtract from 180, and in quadrant 4, I'd subtract it from 360. When you're done, now you're going to take one of each of these answers and you actually need to plug it in to check your answer. So if you look here on the top right corner, I have x is equal to 30. Well, I plug that into my calculator. Tangent of 30 would give you 0.577. Then in your calculator, what I would do is I would go tangent of 30, I would square it, and then multiply it by 2. Make it negative and add it to 1. Well, that's the square. I still need to take the square root of that. So when I take the square root of that, you'll see that it also gives you 0.577. So in fact, the left does equal to the right. So that means both these answers, 30 and 210, 30 and 210 do work. But then I have to check the second, which is plugging in 150 degrees in. So again, I'm going to do the tangent of 150, that's negative 0.577. Then I'm going to square it, so square it, and then multiply it by negative 2, and add that to positive 1, and take the square root of it, and I get positive 0.577. So I see that the left does not equal the right in this case. So therefore, x is not going to be equal to this 150 or 330. My only answer is going to be that 30 is equal to 210 degrees. And that concludes your problem number 10. Now looking at number 11, we have that cosine x minus 1/2 and times sine x plus 1/2 is equal to 0. Now what I'm going to do first is you're going to set the first equation equal to 0, or you're going to set both of them equal to 0. So I have sine x or cosine x minus 1/2 is equal to 0, and then sine x plus 1/2 is equal to 0. Now what you're going to do is you're going to solve each of them for sine x and cosine x. So the first one I'm going to do is cosine x is equal to positive 1/2, and then sine x is equal to negative 1/2. Now, what I'm going to do is I have to find where cosine is equal to a positive ratio. Now, using the chart, all students take calculus. I know everything is positive in quadrant 1. So I'm going to say that cosine is positive here. And it's also going to be positive in quadrant 4. I label my sides adjacent over hypotenuse. So the adjacent is 1, the hypotenuse is 2. I know that that's a 60-degree angle between 1 and 2 on the 30, 60, 90 triangle. But remember that our answer has to be in radians. It says between 0 and 2 pi. So what I'm going to do is I'm going to go to my snowflake chart. Well, my snowflake chart for 60 degrees means that I can fit 60 or 30, 60-degree angles between 0 and 180. So I have a line here, 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 and here. And starting at 0, I would count. So for the first one, it would be 1 because it's in quadrant 1. It would be 1 pi over 3 would be my first answer. 1 pi over 3. It's in quadrant 1. It's going to be pi over 3. Now for the second one is in quadrant 4. So I actually have to count all the way around. So I'd start at 0. This would be 1, 2, 3, 4, 5. So my second answer would be 5 pi over 3. Now I'm also going to show you how to do this if you don't know how to do it in radians, and I will have you put it in degrees and then convert it. But we'll do that at the end. Now for the second one, I'm looking for where sine is negative and sine is positive, I know, in quadrants 1 and 2. So therefore it's going to be negative in quadrants 3 and 4 right here. And I'm going to label my side as opposite over hypotenuse. So opposites as -1, hypotenuse as at 2, meaning that my adjacent is going to be root 3 and negative root 3. Now for this one, because the angle is 30-degree angles, I know that there can be 6 30-degree measures that can fit between 0 and 180. So I would make my snowflake chart look like this. That has 6 lines in between 0 and 180, and then starting at 0, I would need to count all the way to quadrant 3, the first 30-degree line in quadrant 3. So I would count 1, 2, 3, 4, 5, 6, 7, giving me my first answer as 7 pi over 6. Now the next one, I would have to count all the way to this last 30-degree angle in quadrant 4. That would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 pi over 6 would be my second answer for that. Now, I told you I would show you how you would solve for if you didn't know how to convert it from degrees to radians. So my first answer, what you would have to do is I would know my first answer is 60 degrees. I would have to convert it each individually by hand by multiplying that by pi over 180 degrees, and you would have to simplify it from there. And you would have to do that with each individual angle. So that would be my first one. My second one is in quadrant 4, so I would have to do 300 degrees, and I would multiply that by pi over 180. And then I would do over here, it would be 210 times pi over 180. And then my last one would be 330 times pi over 180. You would see that they would all simplify though to the correct answer because 60 goes into 180 3 times. That would be pi over 3. This one you could simplify as well. You could cross out those zeros. 30 and 18 are both divisible by 6. So that would be a 3. And this would be a 5. So 5 pi over 3. So it would just take a process of simplification if you wanted to do that way, but it is possible to just do it in degrees and then convert it. So that's how you would accomplish number 11. Now, what you need to do is I would like you to pause and then try number 12, and then I will do it with you. So for number 12, the first thing that I'm going to do is I'm going to convert this from logarithmic form to exponential form. Now, remember that your base would be 3, your exponent is y, and then your number is x. So that would be x equals 3 to the y. So if I made a chart here, this time you wouldn't be plugging in for x, you'd actually be plugging into y. So I would do -1, 0, and 1. Now, if I plug in -1 into this, my x would be equal to 1/3. If I plug in 0, it would be 1, and then if I plug in 1, it would be 3. So when I draw this on my chart, it would be over 1/3 down 1. The next one would be over 1 up 0. The next one would be over 3 up 1. And so our exponential form would look a little different because it's going to be tipped over on the x-axis and not on the y-axis. Okay, so that's how you do number 12. Convert from logarithmic form to exponential form, and then plug in your variables just like you would before. Now, if you would like, you can pause the video here and then try numbers. I'm going to do numbers 13, 14, 15, and that's it, 13, 14, and 15. So you can pause the video here and then attempt those problems before you unpause it to make sure you know you're doing it right. So for number 13, I'm going to start with 4 plus 3i. Now, 4 plus 3i, 13a. Remember that your whole number is going to be your left and right. Your I is going to be your up and down. So if my 4 is positive, that goes to the right 4 and then up 3. That will be in quadrant 1. Goes 4, then 3. I need to solve my hypotenuse and then my angle. And then your result is going to look something like this. So it's hypotenuse and CIS angle. Now you're going to find the hypotenuse using Pythagorean theorem. So h squared equals 3 squared plus 4 squared. So that would be 9 plus 16. So 25. Now when I take the square root of h squared, that means that h is going to be equal to 5. Now to solve for the missing angle, we're going to use inverse tangent. So it'd be inverse tangent of opposite over adjacent. So opposite would be 3, adjacent is 4. And in your calculator, you're going to do this part first. So it's 3 divided by 4 equals, then second tangent. And that gives me my angle of 36.87. Now my answer is going to be written in this format. So my slant is 5, and then CIS, and the angle is going to be 36.87 degrees, and that will be your result for part A. Now part B is I'm going to go backwards. So again, this is my slant, this is my angle. But CIS, remember, it stands for something. CIS actually stands for cosine plus I sine. Excuse me. So I'm actually going to expand the CIS to cosine plus I sine. So this would be 5 times cosine of 150 plus I sine of 150. Now 150 degrees is going to be in quadrant 2, where the angle is going to be 30 degrees. So my adjacent is going to be -√3, my opposite will be 1, my hypotenuse will be 2. Now the cosine of this triangle is adjacent over hypotenuse. So this would be 5 times -√3 over 2. The sine of this triangle will be opposite over hypotenuse, so that would be 1 over 2. Now all you're left to do is to distribute your 5, giving you a result of -5√3 over 2 plus 5 over 2 I, and that would be your result for converting from polar form to rectangular form. Now hopefully you've attempted these two problems for number 14 and 15. So when you're multiplying, this one says to multiply these two polar forms together. You multiply the outside numbers and then you add the degrees. Now remember to make sure you pay attention to what the problem is asking. So for number 14, when I multiply 3 times 2, I get 6. And I add the degrees 40 and -30, which would be 10 degrees. It actually says to leave my answer in polar form. So that would be the conclusion of number 14. And now lastly, we're going to look at number 15. Number 15 says to multiply and then express your answer in rectangular form. So you will need to expand the CIS after that. So for number 15, when I multiply 8 times 2, I get 16. And then when I add the degrees together, negative 450, I'm going to use a calculator, plus 60 gives us negative 390. Now, negative 390 is greater than 360, so I'm going to add 360 to that, and I actually get negative 30. So when I expand this, I'm going to do 6 cosine of negative 30 plus I sine of negative 30 degrees. And now I'm going to evaluate that. So negative 30 degrees is going to be in quadrant 4. This is a 30-degree angle here. My adjacent will be root 3, my opposite will be negative 1, and my hypotenuse would be 2. Now the cosine of this triangle would be adjacent over hypotenuse. So that would be root 3 over 2. The sine of this triangle would be opposite over hypotenuse. Should be negative 1 over 2, but don't forget your I. And lastly, you're just going to distribute the 16. So 16 times root 3 over 2 would be 8 root 3, and then minus 8i. And that is your result for number 15. So for number 14 and 15, multiplication, just multiplying the outside numbers and then adding the degrees. If it asks you to express it in rectangular form, you do need to expand your CIS to cosine plus I sine, and then evaluate your triangle from there. You're not to use a calculator on either of those problems, except when you're adding the degrees. You can't use your calculator to evaluate your cosines and your sine. So that concludes your new material from lesson 66. I hope you guys all have a great day. Bye.